Hi everyone and welcome. Today we're going to be talking about factoring polynomials. So your goal after watching this video will be able to factor some binomial and trinomial terms. So just like we did before, we're going to call us back to the foundation of why this all works and what we want to focus on here. And that is relying on area. So just like we talked about before, we can calculate a total area by adding up these terms, things that we know, but we can actually do it the other way around too. So like this first example, we have 9 square inches here. If they gave us one side is 3, and they didn't tell us what the other side was, say they said that was an x, we would know to get to an area of 9, length times width has to equal 9, so 3 times x, we'd be able to plug in, okay, x has to equal 3, otherwise this won't work. That's kind of what we're doing today, is we're doing the opposite. So maybe say for these here, sorry if you can hear Winnie in the background, he wants to do some math too. Say they don't give us this 3 term, they give us an x here, but they do tell us the area is 12. Our goal today is to be kind of chunk by chunk, piece by piece, breaking down some of these things on the inside and doing it the other way around. So instead of doing the 3 times 4 to get 12, we'd see 4 times x equals 12 and basically backing it out to get the x. So again, same thing here. Maybe they're not giving us what the top is, and they're just telling us, okay, we're going to see the inside of this is x squared and 3x, and it's going to be our job to say, okay, x times something gets us x squared, and x times something gets us 3x, and we'd have to go backwards and say, okay, x times x is x squared, and 3 times x gets us 3x. That's the only way that that's going to work there. Okay, so again, still relying on area and actually very similar types of questions. The only difference is instead of multiplying things, we have to more or less fill in the blanks here for these puzzles. So the first term that we are going to take a look at is GCF, or greatest common factor. And the GCF is the largest term each part of an expression is divisible by. So if we had a number like 4 and 8, the way that we do this before is we would list out all of the factors for these. So what things can we multiply each of these by that would get us to an answer of the terms? And we're going to see here the greatest one they have in common is 4. Because again, 2 times 2 is 4, 1 times 4 is 4, 2 times 4 is 8, 1 times 8 is 8. We're going to see the biggest one they have in common is 8. So the GCF of both of these terms is 4. Now this gets a little bit more complicated when we add things like variables, but nonetheless the process still remains the same. So for our first one here, we're going to take our 2 terms. We have 4x and we have 2. So what components make up each of these terms? So my advice when you're going through these is to actually break this down a little bit further. So to look at it not just as terms, but look at it as, okay, there's my 4, there's my x, 2, and then there's no variable there. So break down the factors by each piece of the term. So we're going to have 1, 2, and 4 here, just an x here, and we have a 2 here. So for both of these, the thing that they have in common, there's only one thing, is actually the 2. So what we're going to be allowed to do here is factor out that 2. So you take the 2 out of both terms, we're left at 2x and minus 1. Because again, 2 times 2 gets us, 2 times the minus 1 gets us to that minus 2 terms, and then 2 times the positive 2x gets us to that 4x term. But what was I talking about these variables, right? So where is that going to apply? Where do I need that? So let's keep it going here for the next term below it. We have negative 3, x to the 4th power. We have 6, x to the 3rd power, and we have 18, x and y. So the negative 3 is just for our factors here, just 1 and 3. X, we have 1, 2, 3, 4 x's that make it up. For the 2, we have 1, 2, 3, and 6, and then 3 x's. And then for the 18, again, breaking this down into each individual section, listing out all of our factors. For the x is just an x, for the y is just a y. So what can we see that all of these terms have in common? Well, first things first, 3. And then secondly, it looks like, okay, these whole bunch of x's here, but the smallest number of x's is actually just 1x. So all 3 of these terms have a 3 and an x in common. And again, we have to make sure all 3 of them have that in common, otherwise we're not allowed to take it out. So we're going to have a 3x on the outside. Then we have to work our way through what goes on the inside. So 3x times what gets us negative 3x to the fourth. Looks like negative x cubed is going to be the only thing that works there. So again, to revisit, 3x times negative x cubed gets us negative 3x to the fourth, this term right here. That's why it needs to be like that. 3x times what gets us 6x cubed. So 3 times 2, and then we still need to put in the 2 x's there. So 3x times 2x squared gets us 6x to the third power, so we're happy with that. And then 3x times 18xy, so 3 times 6. We have the x that we need, so just y. So 3x times 6y gets us 18xy, so that works. So we actually just successfully factored this one here. We successfully factored that one there. So let's do the same thing. So I'll help you set this up. So list out the 14, the x squared, the y squared, the 42, the x and the y cubed, and use that to find the GCF. And then put the GCF on the outside and make sure that you can factor it in to get to that original answer that we started with. All right, so that's GCF for us. Now we're going to take it to that next step when we are looking at something a little bit more complicated. So again, we're going to be relying on the box method. So a quick recap. I know of a video that we watched either earlier in this week or last week. So the box method. And again, this is a model that relies on area as a concept to factor polynomials. So a quick recap here, if we're looking at that first example that we did, is as we're factoring, once we find the GCF, we can put that on the outside here, so something like 2x. And if we know that our final answer needs to be like 2x squared y, and then, maybe just 4x here, we have to multiply 2x times something to get us that answer, 2x times something to get us that answer. When we fill in these blanks, we're going to see, okay, this is 2x times xy, and this one here is going to be 2x times actually just 2. So the final answer for the factored form of this is 2x times xy plus 2. Check our work real quick. If we distribute that in, we would get 2x squared y plus 4x. So that would work. So that's how we'd use the box method to kind of back out what we're looking for. Kind of doing it in that reverse pattern. All right. So now we have trinomials. Like it's a little bit more complicated. So still make your box. 2x2 binomial box here for these 3 terms. And a couple of rules for the box method. So always, always, always you know your first and last. So your first term and your last term go in your first box and your last box. You know that 100%. Next, when we're going through these, if we ever have that x squared in the top corner, we know our edges have to be x and x. And it's our goal plugging in this box to see what like terms combine to get us the 8 that we're looking for. So your next job is to take the 12 and to break down all of its factors. So 1 and 12, 2 and 6, 3 and 4. And the final job to do this is we are going to take whatever this sign is here, that positive, and we get to use that as kind of a cheat code. So we put the positive here, positive here, positive here. So these are the factors, the things that multiply to get us 12. And if we add them together, what we're going to notice is that 2 plus 6 equals 8. Those are the terms that we want and that we need, because when we use 2 plus 6 to equal 8, that will get us our middle term of 8. So we'll have the 2 here, the 6 here. So we're left with a 2x, we're left with 6 times x is 6x. That gets us the x squared plus 8x plus 12 that we need. So the factored form of this, our final answer is x plus 2 times x plus 6. And instead of having to guess and check, again, list out the factors, use that as your little cheat code. All right, let's do an additional example here. We'll do it on the bottom left. Again, always, always, always the first thing you're going to do, first and last, x squared and minus 6. Again, x squared in the top corner means we know we have our x and our x here. And then finally, we have our negative 6. So 1 and 6, 2 and 3 are the only answers. And which one are we going to use? Well, look at that negative sign. Let's punch that in. So we're going to have negative 5 here, negative 1 there. What digit are we looking for? We're looking for a 5. Okay, so note, this -5 is not what we wanted. We wanted it to be +5. So that means we should be switching our signs around. So we had the wrong number was negative, wrong number was positive. We still need to make sure one of them is negative and one of them is positive, but we should flip that order around. So we'll have +6, we'll have -1, and let's check that real quick. So 6x minus x diagonal does get us that answer of 5, and we're left with the answer of x plus 6 and x minus 1, and we have successfully factored. And again, use that little trick with those factors on the side there and those signs, and that'll help you fill in the edges of the boxes on examples like this every single time. All right, the final step here, I know this is hopefully some review from Algebra 1 for some of us, is we're going to take it to that next Algebra 2 level. So we have to do two things at once here. We are factoring out the GCF, and we are going to be doing our box method right after that. So just to get us set up here before we draw a box, we need to look at our 2, our x squared, our 28, our x, and our 96. List out our factors. And it looks like with 2 kind of being the limiting factor, we might not even need to do a whole lot of work for 96 as long as we know that it goes into 2. Maybe we can just write out the 2, the 48, and the 96. No variables there. So it looks like the only thing these things have in common is actually just that 2 term. Okay, so let's change this to 2 times x squared plus 14x plus 48. Okay, so we factored out the 2. That's the first step. And now the second step is actually just to take this and put that into a box. So again, we know our first term, we know our last term. Put those in right away. That's step number 1. And then next we need to list out our factors of 48. So we're going to have 1 and 48, 2 and 24. 3 is divisible there, so I think that's 1, 18, 16, 4 and 12, 6 and 8, and I think that's all we got there. Okay, so what sign do we have? It's a positive sign. So let's go through and see which one of these we like. $14 is the number we're looking for. It's also positive, which helps us. So it looks like 6 and 8 are going to be the numbers that we use on the edges of this box. Check our work though. 8x here, 6x here. Put those two together, we get 14x, so we're happy. So final answer for the factored form of just this box is x plus 6 times x plus 8. But don't forget, we still have this 2 on the outside that we need to bring down. So our multi-step, multi-factored question is 2 times x plus 6 times x plus 8. So big questions there. So as always, any questions, let me know. Some good factoring review and also some next steps putting multiple forms of factoring together. As always, questions, like